Alright, so this is Rory. I'm here today at the Windows Mobile and Embedded Area Center. What do we call it?
It's part of MED, the Mobile Embedded Devices Group.
Okay,
yes.
So MEDG.
Yeah.
Yes, okay, so I'm here at MEDG with...
I'm Mike Hall.
Okay.
And also here is...
Derek Snyder.
Okay, so we got Mike Hall and Derek Snyder. Derek, what do you do?
So I work on the developer marketing team for Windows Mobile. And that's mostly just dealing with ISVs and developers alike and the way that we think about getting their assets out to our common customers, whether it be mobile operators or OEMs, or also the end users.
Okay, cool. And you brought with you, and we're going to look at these a little later.
Loads of gadgets,
just a bunch of little gadgets down there.
Absolutely, from
so that's really
the treasure
cool.
drawer, absolutely.
And that one's brand new right there.
So this one's brand new, yeah, so my attention always goes to this one. Yeah, it's sold as the T-Mobile Dash here in the States, but otherwise it's available worldwide as the HTC Excalibur.
That's what I'm going to try to steal before I leave here. Okay,
Yeah,
so
cool.
now we head
Good,
back over to Mike Hall. And Mike,
Yes.
what do you do around here?
So I work in the embedded portion of MED. MED is the Mobile and Embedded Group, and embedded covers 3 different operating systems: Windows CE, which you may have heard of, Windows XP Embedded, and also Windows Embedded for Point of Service. So there are 3 different operating systems. My role within the embedded group is, my title is Senior Technical Product Manager, but the role is much more of a kind of a developer evangelist type role. Yeah.
Can you tell Mike's talked about this before?
No,
yeah,
never.
So you just mentioned there were 3 different operating systems.
Yes.
And this is a point of, I don't know if I want to say confusion for people. I mean, it's not for me because you've explained it all to me before. But, you know, for the rest of the world that doesn't understand the difference between, you know, I mean, what is Windows CE? What is Windows XP Embedded? What does Windows Mobile mean? What does all this stuff mean, right? Like,
Sure.
can you give us the rundown? What is the difference between these things, you know, in that clear Mike Hall way, so that people walk away totally understanding, well, what they just heard, I suppose.
Good. That sounds like a plan. Right, let's
start there.
So I'll start with Windows CE.
Uh-huh.
So Windows CE is a small footprint, hard real-time embedded operating system that runs on a whole different range of hardware and processors. So you may think of Windows CE running on, certainly on Windows mobile devices, like this guy here, but it also runs on devices like this guy. This is a board that I'm currently using to prototype an electronic picture frame that we'll be showing at the launch of CE6, which is coming up on November 1st. So I've built a customized operating system, I've booted that down to here, and it's currently displaying up on here. So Windows CE is a small footprint, starting at about 300k bytes for a kernel-only operating system image. The operating system scales depending on the features or technologies that you add into the operating system image, with CE6, which is our upcoming release, which is also our 3rd generation of CE kernel, and I'll talk about that a little bit later.
Okay.
We have about 700 individual operating system components or features that a developer can choose. Think of a box of Lego, right?
Like what? Name a couple components.
Web server, HTTP web server,
Okay.
.NET Compact Framework, web browser, media player, support for sockets, support for...
So it's like BYOOS, build your own OS.
Yes,
Okay.
absolutely yes. So
Yeah.
you can think of a box of Lego, and the box has got 700 bricks in it, and as a developer, you obviously have some idea of the device you're going to be building, and CE has been built into a whole range of kind of strange and interesting devices, from cow milking machines to sausage making machines.
Are you serious about the cow milking machine?
Yes.
Wow. Okay.
Heart monitors to Windows mobile devices to electronic picture frames to point of sale devices, a whole range of systems that you may not even think about using an embedded operating system. So as the developer of that device, you know whether you need a UI, you know whether you need networking, you know whether you need support for serial connections or whatever else, right? So you basically go into that box of Lego and you have the ability to pick and choose the individual bricks and configure the operating system to match your very specific needs. The operating system itself runs on 4 different processor architectures. You obviously know about Windows XP running on x86, so it's PC architecture, PC processor, if you like. Windows CE is an operating system, also runs on x86 processors, but also runs on the ARM family, so ARM, strong ARM, X-Scale, and that's what most of these Windows mobile devices are running on the ARM processor. Also runs on the MIPS family, as well as the SH processors from Hitachi. So again, as a developer, you get to choose whether you want to be x86, ARM, MIPS, or SH.
Why
based.
might I choose one over another?
Well, each of the processors has different strong areas. So if you think about x86, x86 is your kind of mains-powered, raw processing power type processor, right? Sure, you get laptops, and you also get devices like UMPC, which are running on the x86 processor. But think of the amount of battery life that you get out of just a regular PC or laptop, right? Typical laptop, my HP laptop over here, I get 6 hours, but I've got a storming huge battery bolted to the back of it to give me the 6 hours, right? Whereas your typical Windows mobile device, you may get days worth of battery life out of one of these guys before you need to recharge it.
So a lot of it is like power management and things like that.
It could well be power management. In some cases, you might be building a device that requires hard real-time support, hardware interrupts being supported in less than 10 microseconds or whatever, right? So again, your choice of processor, choice of hardware, all plays into that aspects of building an embedded operating system as well.
Okay.
So CE as an operating system is just approaching 10 years now. The first release was 1996, and here we are, 2006, just about to release CE6. This is our third generation of CE architecture that we're rolling out. The first version, version 1, was a soft real-time operating system.
What does that mean exactly, soft real-time?
Well, okay, let me give you a kind of a short version of soft versus hard real-time. So you can think of something that's counting candy bars in a manufacturing line.
Okay.
And if it misses one of the bars because it wasn't ready in time to count the bars it went by, a box may end up with 11 candy bars instead of 10.
Oh, and somebody's going to get an extra candy bar.
Right.
Okay.
And so somebody doesn't lose an arm or a leg or something like that, but they're happy they've got an extra bar in their box, right? Unfortunately, the person right behind them might only get 9 in the box, but again, you know, it's no big deal if there's one too many or whatever in the box. So soft real-time can deal with problems. Hard real-time, you have to guarantee that if a hardware interrupt fires, that you'll not only pick it up, respond to it, but also be ready for the next one before the next hardware interrupt comes in. And you can think of industrial robots, industrial control systems, these kind of devices that need hard real-time. A good example would be the KUKA robots that are used to manufacture cars, manufactured in Europe, but also being used by Lego, actually, interestingly. If you go to any Lego park, they have these, they're called robo-coasters, running on Windows CE, hard real-time support, and you get to strap yourself into one of these things. It's basically an industrial robotic arm that stands about 40 foot straight up in the air, where they've taken the manufacturing arm off the end, bolted 2 seats on it, and you get to strap yourself in and, using a touch display, kind of recreate your own custom roller coaster ride in effect.
Wow, so Windows CE is running this potentially dangerous, really extraordinarily huge, powerful machine.
Yes.
It's that reliable.
Yes,
that's good
course.
to know. Okay,
yeah,
that's actually really good to know.
Real-time, reliable, robust operating system.
Yeah, sure, all the cool keywords. Yeah.
The code base for CE is completely different to that of the desktop. It's built from the ground up. The architecture is completely different. If you have a look at the interrupt architecture, different. If you have a look at the APIs supported on the operating system, the API set is very similar to the desktop. We support Win32, we support MFC, we support managed code through the Compact framework, but porting applications between the desktop and CE tends to be an amount of work. When you think about Windows CE, version 1 through to version 5, through the memory architecture, the virtual memory layout of the operating system only supported a maximum of 32 processes running at one time.
I didn't know that.
And each process ran inside of a 32 meg virtual address space. So 32 meg VM and a maximum of 32 processes. In effect, what we had, so it's a 32-bit operating system, C. So you can divide the operating system into a 4 gig address space, 2 gig for kernel, 2 gig for user space. And in the user space, each process was given a 32 meg slot in that 2 meg space. So the current running process was slot 0, the base 32 meg. Above that, you had another 32 meg set aside for execute in place ROM-based DLLs. And then the other slots above that were for other running processes. So for a process to run, it needs to be moved from its slot down into slot 0. And then, of course, that may be paged out to now allow another process to be kind of paged in. So there were limitations. Windows CE version 1 through to version 5, 32 processes, 32 meg virtual memory per process. Windows CE version 3 is when we introduced hard real-time. So that was the second kernel. First kernel was version 1 through to 2.12. Version 3 was the second kernel, and now with CE6, which is being released in just a few days, is our third generation kernel, and we're making some fairly fundamental changes. So previously 32 processes, 32 meg VM per process. With CE6 we're supporting 2 gig virtual memory space per process, 2 gig.
Wow. Okay.
And supporting up to 32,768 processes running at one time on the operating system.
Okay.
So,
a little different, yeah.
A slight change coming up. Even though the kernel architecture is changing, the majority of existing CE5 applications just work unmodified in their binary form, because the API set that's being exposed on the operating system really isn't changing, right? There are some changes. There are a few APIs that were supported in CE5 that are no longer supported, such as setk mode, the ability for a user mode process to be able to, in effect, step into kernel space and touch memory and hardware. So that has now been taken out. Set proc permissions, the ability for a process to read-write to another process slot, because the slot-based memory model doesn't exist anymore. So there's a lot of memory protection going in with CE6, obviously expanding the virtual address space for each process as well as the number of processes that can run.
Wow.
So fairly major changes.
Yeah, very, very different.
Okay, so that in effect is what CE is.
Before we get away from CE, what does CE stand for?
Well, it depends on who you ask.
I'm asking you, Mike Hall.
Well, I think it stands for Cool A.
Okay.
But of course, if you kind of go back in history, people think it stands for Compact Edition because it's small footprint, real time. Other people think it's consumer electronics because of the type of devices it's being built into. Really, it doesn't stand for anything.
Does anybody really know? Or
it doesn't stand for anything.
They just made it up?
Yeah.
All right. Okay, so that's Windows CE then.
CE. So we can do two things at this point. We can either give you the comparison from what is CE to what is Windows Mobile, or we can explain the other embedded operating systems and then come back to Windows Mobile. What would you like to do?
Well, I'm getting the feeling, okay, so Windows CE is like the base operating system. It is a base operating system that you build up yourself and you use in different devices. Why don't we compare that to XP Embedded and then move on to what does it mean, once we've got those two foundations down, what does it mean for something to be Windows Mobile, for example? Okay,
so we've got CE, small footprint, 300 kbytes, kernel-only image, right? Runs on 4 different processor architectures. Okay, so that's the baseline that you need to work from. Windows XP Embedded is Windows XP Professional Service Pack 2 componentized. So in effect, you take the entire XP binaries, you break them up into 12,000 individual components, 9,000 drivers,
wow,
and 3,000 operating system technologies. And you put a set of tools around that give you the ability to, as a developer, pick and choose exactly which components you want for your embedded design. So typically when you boot an XP machine, you get the standard kind of XP desktop with the start button and icons and those kind of things. Well, that's known as the Explorer shell. The Explorer shell is one of the components in that tree. So if you want to boot your system up, in fact, this guy that I've got here, I've written a managed C#.NET Framework 2 shell for a demo that I'm giving next week, and this is booting off of this USB disk on key.
So you just wrote your own shell?
Yeah. A
shell
for Windows XP Embedded.
Just take a look at it here.
The shell for CE or XP Embedded is in effect just an application. Right?
Okay.
I've got a number of buttons along the bottom here. These are nice kind of aqua buttons. The one marked Starbucks on the end here in effect just exits the shell, and to prove that it's a shell, if I touch that, it exits the shell, and because it's the shell, it instantly gets restarted again, right? And there we are, back to the launch site for CE and XP Embedded next week.
That's cool.
So this is booting and running directly off of a USB disk on key. For the demo, we're booting this in a external USB slot. But if this was a real embedded device, like a kiosk or an ATM machine or whatever else, this would be on an internal USB bus, so it would be shipping as part of the hardware. Obviously for development and diagnostics it's really useful to be able to plug externally. Right. So Windows XP Embedded, componentized version of Windows XP, 12,000 components, the tools that sit around that allow you to pick and choose which components you want for your embedded operating system. But there are a set of embedded enabling features that go on top of XP and beyond XP. one of which we've already seen, USB boot, the ability to boot an operating system from a USB disk on key. We also have features such as EWF, the enhanced write filter, that gives you the ability to boot your operating system from read-only media like Flash or from CD. Okay, Flash isn't read-only,
right,
but Flash typically only supports a limited number of write operations, so you want to protect that Flash media. In effect, mark it as read-only, boot the operating system, your custom shell and applications off of that Flash. And of course, if you use FileMon and RegMon from systeminternals.com, and just to look at a regular Windows XP desktop operating system running, you'll see that the file system and the registry is getting hit all the time. So if you're booting from CD or from Flash that's been marked as read-only, what happens to all those write operations? Well, with EWF, we intercept the write operations, and instead of writing to the media, of course you can't write to a CD, in effect we redirect to an in-memory cache. So the operating system itself doesn't need to change, right? The applications can still write to the underlying file system or to the registry, but instead of touching the physical media, those write operations get redirected.
So the app just doesn't really know. It just thinks that it's, yeah,
right.
Cool.
So you don't have to rewrite anything. With an upcoming service pack release or feature pack release for Windows XP Embedded, so this is known as Windows XP Embedded Service Pack 2 Feature Pack 2007.
Wow. Okay.
There is an enhanced version of the enhanced write filter, which is known as the file-based write filter. And the file-based write filter is very similar, protects the entire volume that you're booting from, or a secondary volume can also be protected. But it gives you the ability to have write-through holes in that filter. So imagine that you're somebody that's building a set-top box, for example, or any kind of embedded system. For a set-top box, you may want some data to persist on the drive, such as downloaded movies or media or photos or whatever, or even the electronic programming guide that you may pull down once every 2 weeks. If you then rip the power out of the back of the set-top box and plug it back in, you still want that information to be stored.
Yeah, people will be mad
if
it's not there.
Right.
Yeah.
So you may want to protect the operating system. You may want to protect applications. So the default setting for the file-based write filter is everything protected. But then when you configure the operating system and build the operating system, you can mark these write-through areas. Either at the file level, this file is read-write, but this file is not. Or at the folder level, everything in this folder is read-write, for example.
Okay, so
that's kind of neat.
Wow. So XP Embedded then is a componentized version of XP, essentially, with 12,000 different components.
Yep.
And just to get an idea, and I'm just curious now, like Windows Server 2003, for example, is it, like, there are different editions released, like the Web Server edition. Is that built on XP Embedded, or is that just regular XP? Okay. But that's the kind of thing you could do, though, where you could say, all I want to do is have, like, IIS, and I only need, the base video driver. I don't need to have, like, 5 billion different video drivers installed. Just the smallest, footprint possible, so that you have the fewest possible points of failure and so on.
Well, we obviously don't want to talk about points of failure.
Well, I mean,
you still want to build a reliable embedded system.
It's the idea that you're going to have this thing probably running in a kiosk or something somewhere, and you want to make sure that people aren't going to have to reboot it, or they're not going to be slapping in some weird piece of cheap hardware they purchased that might cause some sort of a problem or something.
Well, there are
right?
potentially two things you want to do. You want to stop people plugging in hardware and doing stuff at the hardware level.
Mm-hmm.
So most real embedded systems are kind of locked down hardware, right? But you also want to stop people doing things at the software level. So maybe when you're configuring the embedded operating system, you want to leave out all of the software components that deal with things like USB keys and CD-ROMs and floppy drives and those kind of things, to stop people trying to install additional programs, drivers, or whatever else.
Okay.
So you can physically lock down the image as well, so there is no access through hardware for the user to do anything. But of course, most embedded systems, you think of an ATM machine, for example. ATM, the only interface that you've got into that thing is your card that you put in and a pad to enter numbers and select options. You don't see any of the rest of the hardware of the unit, right? So physically it's secure, and there is no way for people to add additional drivers or apps or anything else onto the system.
Okay.
With Windows XP Embedded, it's Windows XP componentized, which means that the operating system runs on x86 processors and PC architecture hardware.
Exclusively?
Yes.
Okay.
So it doesn't run on ARM, MIPS, or SH4, unlike CE. The minimum footprint is about 40 megabytes in size, 40 meg, compared compared to 300k bytes for CE. XP Embedded is not a real-time embedded operating system, but there are a number of third parties that do have real-time extensions that could be added to Windows XP Embedded to give you real-time performance. In effect, it's a secondary kernel that runs at the same time that provides real-time response with a set of APIs that a Win32 application can talk to.
Interesting. Okay.
So Windows XP Embedded componentized, some embedded enabling features on top of XP, 40 meg minimum footprint, and you grow that depending on the features and technologies that you add.
Okay, so I understand the differences, from a technical standpoint. I mean, to summarize, Windows CE is built for, different processor architectures, and it can be used for all these different systems. XP Embedded is essentially a componentized XP. What are some of the different applications that you might, want to put each one of these to? Like, why would you choose XP Embedded over Windows CE, for example?
Okay, so Windows XP Embedded typically gets put into mains-powered, always-on type devices. So this would be information kiosks, this would be point-of-sale terminals, this would be ATM machines, this would be, if you're heading out through reception of this building, take your camera with you, and you'll see a large Rockola jukebox.
Oh, I saw that, on the way in,
Right, so that's also running Windows XP Embedded, that's why it's in reception of this building. And the neat thing about that is it has internet connectivity, so as Rockola release more albums or tracks or whatever that they want the jukebox to be able to play, it can just pull them down from the Rockola secure site and update its own catalog of music as it goes without having to send an engineer out or somebody to update the machine.
Cool.
So typically devices that need great graphics, obviously anything that Windows XP can do, you can also do with Windows XP Embedded. So there's all support for DirectX, great graphics, great sound, movie playback, audio playback. All of the hardware that's supported by standard XP is just supported natively by XP Embedded.
So where with Windows CE we wouldn't expect it to support, like the latest video card from ATI or NVIDIA or something like that, you can expect that from XP Embedded. So if you need to have a highly intensive graphics application or something, then okay.
Well, interestingly, most XP Embedded devices that go from concept to shipping in about 14 weeks, start to finish.
Wow.
Which for embedded devices is rapid, right? Totally rapid. In the case of CE, in most cases, and I thought I had an interesting board kicking around here somewhere. Yeah, here we go. In the case of CE, typically people will be building custom hardware to run the operating system. So this is a TIO map, ARM-based board. As you can see from the board itself, it's got a USB connector and an SD slot, but there's really nothing else there. Right? So there's no video out, there's no networking or anything else. So in this case, when you build the hardware, you need to port the CE operating system to the hardware, which means creating things like bootloaders and device drivers. In the case of CE, the CE operating system ships in a mixture of source and binary. So with CE6, and we're going to be announcing this, I guess, on November 1st, we're shipping 100% of the kernel of CE in shared source, which gives you the ability to completely look at how that works, to modify the code, rebuild it, ship it, do whatever you want with that, as well as other portions of the operating system in source as well. In the case of CE, you build source to generate the final operating system image. In the case of XP Embedded, you're pulling together pre-built binaries to generate that final operating system image.
All right.
Yeah.
So you want to talk now about Windows Mobile? Should we move on to that?
Yeah, let's talk about Windows Embedded for point of service.
Okay.
I like you, Mike. Interesting.
And we'll come back to Windows Mobile in just a second. So this should actually be a fairly quick conversation. So a very close relative of Windows XP Embedded is Windows Embedded for point of service.
Okay.
It's an installable operating system rather than a set of Lego blocks that somebody will plug together. It gives you a baseline image for point of sale, point of service type devices that you can simply take and install a CD, put into a device. It will install this thing called Windows Embedded for point of service, which is based on Windows XP Service Pack 2, but the entire operating system image is about 300 to 400 megabytes in size. You do have some options of including a media player and internet browser and those kind of things. But for the most part, people will be using this underlying operating system infrastructure to build information kiosks and retail point-of-sale terminals and those kind of things. The interesting thing about Windows Embedded for Point of Service is that it has this managed interface layer, a set of managed libraries, which abstract something called UPOS, which is the Universal Point of Sale, Universal Point of Service APIs, which are an industry standard, so that as a developer, you can very, very quickly and easily write applications that target point of sale hardware without having to know too much about the hardware itself.
So when you say managed,
yes, carry on.
when you say managed,
Yeah.
what do you mean exactly? You're talking about
.NET Framework based
so
applications, C#,
wow,
VB,
so you have
whatever
this nice
else.
abstraction just sitting right on top of it. So then the idea is to, did this come about because there were so many people who were using XP Embedded for this particular purpose that the idea was to create a system that could be used much more rapidly or much more readily for this, or?
Partly yes, but there's another side to this as well. Think of desktop PCs. On the desktop, when you get a mouse or a keyboard or any other kind of fairly standard hardware, USB webcam or whatever else, you typically expect to just be able to plug it in and it just works, right?
Yeah.
Get any kind of mouse, plug it in, within a few seconds you get the beep beep and you're off, right? In the case of retail point of sale, point of service type devices, for the last 10-20 years there has been no concept of plug and play. So if I had a USB barcode scanner or a serial 2-line display, as the developer I'd have to write all of the code line by line to deal with that very specific piece of hardware. So there's a ton of work that needs to be done in order for somebody to support what would appear to be a common set of retail peripherals. So I could go out and buy a barcode scanner from Handheld Products, a separate barcode scanner from Symbol or somebody else, and my application would have to know how to deal with each one, right? So the Windows Embedded for Point of Service product abstracts at the device layer things like barcode scanner and line display and cash draw and scales and credit card swipe and all these kind of really interesting devices, about 20 different hardware categories. So as a developer, you just write your code against the generic line display and don't care about the manufacturer or the infrastructure that deals with that device. It could be on a serial connection, it could be on a NET connection, it could be on a USB connection. You don't care. You just write to line display and it just works. So to support
really cool.
a USB barcode scanner or a barcode scanner, let's forget USB, barcode scanner in general, for a .NET Framework developer, that's typically 10 lines of code. 10 lines of code to support any barcode scanner. And in effect, you could plug in a Handheld Products, scan some barcodes, unplug it, throw it away, get a different one from Symbol, plug it in, without even shutting down the application, without rebooting the machine, and you're up and running again in a few seconds.
Nice.
Right. Interestingly, we were just about to launch Windows Embedded for Point of Service, and on my blog, I put a question out there. Hey, how many lines of code would it take for me to write a very simple application that runs on my desktop, that supports USB barcode scanner, so I can scan barcodes, and all I want to do is display the barcode information inside of my application, like within the client area of the application. Knowing that the answer was 10 lines, and this was on a Friday, so I went away for the weekend, came back in on the office on Monday, hoping to be able to post up, surprise, it's just 10 lines of code kind of thing, right? And some guy had spent the whole weekend writing close to 10,000 lines of code,
Oh my God.
native code, and like and here it is, and but if you're changing the make or model, be aware that you need to make some changes to the code. So at that point, I'm thinking,
So he did it in 10,000 lines.
Yeah.
Wow.
it's just like, ooh, do I want to tell him this? You do it in 10 now. So that was interesting.
Yeah.
So anyway, that's Windows Embedded for Point of Service.
Okay.
Which
Well,
is pretty
good.
neat.
Sounds like it can save you up to 9,992 lines of code.
Indeed.
Or 9,990. Sorry, I
Yeah.
forgot it was 1098. But yeah, okay. Well, very good. Very good. So now
let's
we move on to Windows Mobile.
Okay. So we've heard about Windows CE. Windows CE, small footprint, componentized operating system. When we build CE, in effect, we have a number of release mechanisms. We release externally to developers that want to build the cow milking machine or the sausage making machine or whatever else. But we also release internally to a number of teams as well. Windows Mobile being one, Windows Automotive being another, MSTV for set-top boxes and those kind of things being yet another group, and so on. So there are a number of groups inside of Microsoft that take CE, the same bits that we post externally to customers, and then tailor that to specific needs. So in the case of Windows Mobile, just like an external developer can look at that bucket of components and say, you know, I need support for networking, I need support for this, that, and something else. The Windows Mobile team do the same thing, but in effect what they do is plug together a set of components that are the same across all Windows Mobile devices. So you know full well that if you get a smartphone, hold up a smartphone, or two different smartphones.
There's two different kinds of smartphones, yeah.
So the one in your left hand is the HTC Star Trek, and the one in your right hand is the
Excalibur.
Excalibur, right? So both those devices are smartphone, but the underlying component technology that's in them, in the case of Windows CE, is exactly the same. So in effect it's a standard platform. From a developer's perspective, there is just one software development kit and API set that they need to target for all smartphones. It's exactly the same platform.
So we could say that Windows Mobile is a version, it's a built-up version of Windows CE that specifies, you know, a certain set of services and, you know, functionality are going to be available regardless of the device upon which it's been installed.
Yes.
That's right, and that's actually a pretty big thing for the cell phone industry itself, actually, because coming from like Java World and coming from, you know, other places you know, that are competitive to us, to basically target 80% of the phone market, you have to actually target 147 different phones, and that's 147 actual different versions of your application if you're writing an app.
So you mean you actually have to write? You literally have to write 147 different versions.
To get to 80% of the market, that's what's true of like Java and Nokia, or at least Symbian. And so with Windows Mobile, though, you know, you're able to reuse 99% of your code, and you know, you may have to do a couple little changes to adapt your app for different screen resolutions and different input, as we're now changing that up a lot with kind of the variety of device choice. But as Mike suggested earlier, I mean, we're constantly using the same set of Legos, to use your analogy.
Yeah.
So you can expect you know, all the same, you know, shell, the same applications that are on top of the platform, etc.
So it's the same virtual memory layout. It's the same number of process limitations as you know, CE5 as it ships today. Windows Mobile 5 is based on CE5.
Okay.
But the Windows Mobile team also do more than that. They also add their own custom shell, they add their own custom applications, they add some infrastructure technologies for dealing with switching between different communication technologies, whether that be Wi-Fi or GPRS or Bluetooth or whatever else.
Does Solitaire ship with Windows CE, or is that Windows Mobile specific?
Solitaire is a component in the component
wow.
database
Okay.
for CE.
That's really cool.
Wow.
So Derek, I'm curious. I want to get back to this
Sure.
the idea about the 147 different versions of the application. So, why is that? I mean, you're talking about Java, right? So
and
why?
Symbian as well. Yeah.
Okay, and Symbian. So why is it that there are all these different versions? I mean, are they writing customized Java extensions, or? I mean, I don't really understand like the Java world over there. Are there like, you know, JNI extensions, and can you even do that with that version of Java with the?
Well,
with the
so
micro
it's
version?
interesting. It's actually because of the device choice that's out there. So unfortunately, there hasn't really been, well, fortunate for us, but unfortunate for them, there hasn't been really a standard across all the feature phones, the kind of what we would consider camera phones out in the market, right? So although, you know, the Motorola Razr may be a particularly hot phone and may sell in huge numbers, that's still just one particular flavor of J2ME that's being, you know, kind of put onto the phone, right? And so then you look at like an LG phone or a Samsung phone, it could be completely different. The screen resolutions aren't the same. Kind of the kernel has nothing to do with each other. So again, going back to, I guess, you know, the Windows Mobile differentiation is the fact that, you know, any developer can fire up Visual Studio and out of the box, or with the addition of SDK for new versions going forward, write for any Windows Mobile device. And so that's kind of really the strength there, especially when you think about what mobile operators require when it comes to certifying and signing your app. Instead of having to sign and certify every single instance of that app, because you've got to spin up 147 of them, exactly. With Windows Mobile, you're signing it once, and it's virtually going to run across all our devices. And so that's you know, not only from a developer pain standpoint, but that's also from a monetization standpoint, a lot more of a more sound model, I guess.
Okay, cool.
So
you want to talk about some of these devices? Show
yeah,
some
sure.
Of these devices?
So we'll get to the kind of the good stuff here. So this one here. Oh, thank you, Mike. This one here is the probably the thinnest, dare I say, razor thin smartphone we have, if I'm allowed to say that. Razor with an O, I think we can say. So it's the Singular 3125. And this one's actually pretty new. It's been out for about a month or so. It's based, as Mike suggested earlier, on the HTC Star Trek platform, so it is available worldwide through other operators and unlocked, and very much the same form factor. As a matter of fact, HTC makes a lot of the devices I'll be showing you here, but they get basically white labeled and relabeled from operators and from OEMs of all kinds. Kind of going down the thin tangent, here's the Samsung i320, which is also known as the Blackjack if you're into code names. And this one really is the thinnest QWERTY keyboard smartphone we have right now. A lot of folks have probably seen the Motorola Q, and that's been pretty hot, but it's largely been limited in terms of its reach because of CDMA network, the fact that it's really only available in the US and Canada. Well, this one is GSM, absolutely. You can hold that right there. This one is actually GSM, so it'll work on a variety of networks worldwide. As you can see, it has the camera built in. And this actually is a unique device because more and more we're starting to see QWERTY keyboards on smartphone, where traditionally QWERTY keyboards were only on Pocket PC.
So that's actually running, that's a smartphone as opposed to Pocket PC Phone Edition.
Exactly. And we're trying to kind of get away. I mean, we're always going to have to differentiate from a developer standpoint, at least in this generation, because they are two different SDKs, even though a lot of the logic's the same. But more and more we're seeing a mixture between the features of the device, right? So no longer is just QWERTY for Pocket PC. Well,
let's stop there for a moment, because I've noticed just in some online conversations I've had recently, there is some confusion between Pocket PC for phone and smartphone. I mean, you want to talk about the difference there? Like,
absolutely,
what
yeah. So, as Mike suggested earlier, we do put a bunch of applications on top of Windows CE, and certainly with our Windows Mobile shell.
Because they're both Windows Mobile, right? So
exactly, they're both Windows Mobile. So really, it's they are built from two different platforms. I hate to say, even though they're all based on the same Windows Mobile kernel and all that, right? So the development experience is very much similar, right? It's still all 32. It's all still Win32 and C# development. But we're looking at between Pocket PC and smartphone at the application layer. Pocket PC currently has Office Mobile, meaning Word, Excel, and PowerPoint. You can edit and view Word and Excel, and you can view your PowerPoint documents. Whereas that's only possible with third-party innovation on top of the smartphone platform right now. And when you may ask the bigger question, well, how do I know which one is a smartphone? Currently, the kind of dividing line for a smartphone versus a Pocket PC, besides the Office apps, is the fact that a smartphone actually does not have a touch screen.
So that's how you can really tell.
That's how you can really
tell. Never
tell.
Have a touch screen.
It's not that that's going to always be the case forever, but currently, right now, that's really the way that we think about the two different platforms. And that's actually kind of a mixed blessing, where some folks like the touchscreen. Having the non-touchscreen really guarantees that it's going to be a great one-handed device, because developers are forced to live within those constraints, right? So, kind of moving on, more and more, we're seeing 3G networks out there. So these two devices here, this is the HTC Hermes and the HTC Breeze. These are actually 3G devices. We actually launched Windows Mobile 5.0 with a 3G device first, which was the HTC Universal, but it was pretty big, had a VGA screen, and it would just swivel around and didn't.
It was almost like a mini tablet.
It looked like a mini tablet, exactly. So now we're starting to see 3G speed in much more digestible form factors.
So for those who aren't totally familiar with the terminology, what is 3G exactly?
So 3G is actually the kind of the next generation of wireless access. So to put this in kind of perspective, it's like moving from dial-up to broadband.
Okay.
So what we have today with standard GPRS networks, or 1X TT or RT, 1XRT on the Verizon network was very, very slow, typical like broadband speeds. Typical like dial-up speeds. And then as we move up, they moved their technology on GPRS side through Edge, which is a little bit faster, maybe roughly close to a little bit the fastest of the dial-up
MSDN
modems you would have. Almost,
okay.
Yeah, exactly. And then now we're getting to the point where we have EVDO on Verizon and Sprint, which is their quote-unquote 3G network, along with UMTS, and then a specific flavor HSDPA on a 3G GSM network. So you'll see more and more.
Three different things. Those are all 3G essentially.
Exactly.
So 3G isn't a standard. It just defines like a speed or a performance level?
Well, it is and isn't. Because along with 3G comes a new standard for the SIM cards that go into the device, and there's new fields for for SIM contacts, and there's a lot of kind of architecture that comes with it, but it really is about the speed. So Verizon and Sprint, to put this in real terms, uses EVDO right now. Singular actually is putting in the groundwork for a pretty large UMTS network here in the States, and Vodafone has a pretty large UMTS network over in Europe.
And UMTS and EVDO are totally incompatible.
Exactly, because we were talking about CDMA standard versus a GSM standard.
Okay.
So one has a SIM card, the other does not. So yeah, this was the device I talked about. So this was the device we kind of launched with, and this was is really referred to as kind of a mini laptop, but you can think as a phone device unless you had a Bluetooth headset. I don't know if it's the best way to get a date on a Friday night. Not sure. Thank you, Mike. But Mike obviously carries that one, of course. Yes. He's all about features. And so getting back on, devices that are smaller like this now have the higher speed network access. And the cool thing that can happen there is that now we have two cameras. But you have a camera for photo taking and then this one for actual video conferencing.
Wow.
Which is something that, isn't really new for a lot of Europeans, but it's really starting to be more and more prolific here in the States. And the cool thing is really the interoperability between these devices and other devices that are even competitive that have cameras as well. So this isn't something I can only call Mike because he has a Windows Mobile device. This will actually call a Series 60 phone from Nokia as well, and they work on the same standard.
So Europeans are out there making video phone calls to each other?
So they have the capability to. It's been obvious through some of the research that's been done that hasn't really caught on yet. Mm-hmm. I don't know if that's because people don't like the idea of being seen while they're talking or seeing where they are, or maybe they just don't want to do their hair in the morning if they're getting on a call.
Okay.
I'm not really sure. I think maybe for the same reasons that webcams haven't really won out over just regular keyboard chat on like MSN Messenger or Windows Live Messenger, for example. So yeah, we do have a lot of phones that they have the slide-out keyboards. This one's built on the PocketPC platform, so again, the touch screen has Wi-Fi and Bluetooth in addition to that 3G UMTS network I talked about. This one actually has a 2-megapixel camera as well. Not that these cameras are really going to replace typical cameras because, of course, they're lacking flash and appropriate ISO and et cetera, et cetera.
But they're getting better.
They're getting better, exactly. Now, for casual photo taking, especially outdoor shots, this really is a pretty good device. And then this is one of my favorites, actually. This is the new Palm Trio. You'll notice it's not really typical of the other trios because it doesn't have the stub anymore. Mm-hmm. This one is actually a GSM UMTS device, so again with a 3G speed, or if you're on a network like T-Mobile which hasn't yet implemented it, it'll still work. This is available with Vodafone overseas right now in Europe. We would expect that it would hit an American operator soon.
What model is
that? For that. This is the Trio 750V.
Okay.
And the V is for the Vodafone SKU that's out right now. So yeah, this is a really cool device. Has the Palm ease of use. So kind of the way that we take CE bits and build Windows Mobile on top of it, Palm goes a step further and they put what they call their secret sauce on top of our Windows Mobile. So imagine like a triple-decker pancake or something.
Do they expose their own custom APIs or anything?
They do actually. Okay. They have a SDK that can be used in concert with our SDK so that you can target specific Palm features.
But if I write a Windows Mobile application that targets the .NET Compact Framework, it'll still run on there?
That's right, absolutely.
Okay, so,
yeah.
so there's extra stuff, it'll still work.
That's right.
Okay.
So unless you've specifically optimized for a specific processor that this device has, or use some sort of weird Intel optimization kit, that's the only time where I think we might get into a little bit of an app compat breakage. But rest assured, if you're just writing with the Visual Studio tools, Visual Studio 2005, it'll run across all these devices that I have here. And then finally, this one is the one I showed a little bit earlier, and this is the HTC Excalibur. And the cool thing is Microsoft IT has enforced a pin lock on me.
Yeah, I got that on my phone too.
Yeah, mixed feelings on that. So this is the HTC S260, but it's actually available here in the States as the T-Mobile Dash. And that's just actually recently became available. Now the cool thing, this actually isn't true of the Dash version, the T-Mobile flavor, but this particular version has a touchpad scroll wheel on the side, so it's not actually a moving part at all.
Oh, I have to. I have to try that.
Try that out, definitely.
Here, I'll bring this up here so that everybody can see it. So
absolutely.
I just with my oops, there's your email. I didn't mean to open your email. That was an accident. So I'll just hit the home button to get myself away from your email. And
it's just letters from Mike, I'm sure.
That's really cool.
Of course.
Wow. I mean, if I had this, I'd just sit around and scroll all day.
Exactly.
I mean,
not that we use these devices in our cars, but if we were to, it might be easier.
So I can go to IE and looking at Borat's profile here.
Yeah, I was Halloween shopping, actually. I needed to figure out what kind of mustache he had.
Okay, so that works for the scroll, too, in IE. That's a nice little interface
Absolutely.
feature there.
So this is definitely probably my favorite device right now but you know, it is the device of the week. But it's really cool, super thin form factor. But again, that's what we're starting to see with the smartphone platform. A lot of folks, as long as they get the QWERTY keyboard, feel like that's enough, right? They don't necessarily need the touch screen anymore, and it's really enabling very, very thin profiles, which this used to be, you know, your keyboard option versus this, right? So we're really starting to get to this tipping point, right, where now the devices have great form factors and good functionality, ease of use, and interface options.
So do we have anything coming out? I mean, I'm looking down at these devices here, and I see that we have, we've got the HTC Star Trek over here, which is 240 by 320. The screen is QVGA, right?
Exactly.
And we head over here, and I mean, like the Universal is 40 by 640.
640 by 480.
Yeah,
exactly.
depending on landscape or portrait mode.
That's
right. And we've got the square screen over here. So do we have anything coming out that's going to make it easier for developers to target the different screens so that they don't have to redo their UIs automatically?
So that is an amazing question. So we have recently, just at the MEDC 2006 event this past year, announced Patterns and Practices Mobile Content Software Factory. And the idea there is that this is a kit that you can install on top of Visual Studio and on top of your Windows Mobile 5.0 SDKs. It's completely free. And what it does is it actually brings in a bunch of DLLs that make that exact kind of programming easier. So there's this new DLL called the Orientation Aware DLL. And what that allows you to do is, within Visual Studio, lay out what the screen will look like in a specific form factor. So suppose I'm targeting portrait first. I can drag it, make it 320 by 240, and then from within Visual Studio, thanks to the add-on of the software package, you can rotate and then relay out the elements, and it'll save those states right into the program. So you're not actually hard-coding any of that anymore. And the great thing about that is it's prepared for the future, right? So if you lay out a bunch of general ideas and you're docking this into your app, you're more likely to be ready for when that yet-to-be talked about screen resolution hits, rather than targeting very, very specific ones that are in market today.
Where do I get that?
So that's actually up at the Patterns and Practices page. You can do a Windows Live search for Mobile Content Software Factory, Patterns and Practices.
You can use your favorite internet search engine to locate.
That's what I just said.
Right.
Company line, man. Absolutely.
All right, very good. So, anything else you wanted to say about Windows Mobile?
No, I think we actually hit on the big ones. Yeah, you asked the $100,000 question. I just think that if you are developing for Windows Mobile now, make sure to pay attention to keeping your application adapted for multiple screen sizes. That's probably going to be the biggest challenge going forward, but also the biggest opportunity. And I'll actually quote something. So developers that optimize their application for the Motorola Q, which was a landscape smartphone and kind of the first of that kind. Those that optimized, they were able to make their entire year's sales on Handango in that first month of optimizing, because they were one of the very few that updated in time, right? Yeah. So, I mean, think about it. It can be a challenge, but at the same time, it can be a great opportunity as folks are going to be hungry for apps for their new phones, especially ones that we think are going to get to huge, huge market penetration. More and more, it's going to create opportunity for application developers that are really producing high-quality apps that adapt across all the devices.
Okay.
So very cool. Thank you for having me.
Yeah. No, thanks for being here. That was really great. Mike, any last words? I mean, just for the video.
Well, no. Hopefully this was useful, and now all the confusion about Windows CE, Windows XP Embedded, Windows Embedded for Point of Service, and Windows Mobile has all been cleared up.
Otherwise, everybody can just email you, right?
Yeah,
with their
of course.
questions. Okay, good.
Absolutely. Yeah.
All right. Well, I guess I'm going to get out of here then. Thank you guys a lot, and I'm probably going to be coming back at some point for some more in-depth discussions about different aspects of Windows Mobile. I want to push, Windows Mobile quite a bit on Channel 9 just because it's one of my favorite technologies at Microsoft, and I'd love to hear more about it and embedded and everything, and just look at the different, maybe look up close at some different, applications of the different technologies so we can get a better idea of what's been done.
Yeah, we could take you for a walk through the development process for building custom operating systems for XP Embedded, CE.
That would be great. What's the tool that you use for
CE? It's called Platform Builder.
Platform Builder,
and
right.
For Windows XP Embedded, it's a small suite of tools known as Windows Embedded Studio that cover Target Analyzer, which analyzes your underlying hardware and generates a component for that. Component Designer, Component Database Manager, and Target Designer. So there are a number of programs that make up that suite.
Well, great. Well, then I'll come back and we'll take a look at that stuff, and it'll be fun. It'll be good.
Sure. Very good.
All right, guys.
Thanks
well, thank you very much.
y'all.
One last time. Bye. Goodbye, Mike, and goodbye, Derek.
See you guys.
And thank you.